having taken our first derivative and our second derivative, we can substitute this expression in for x double prime, and we can see that what we have is negative k over m times our original function, the b cosine and the c sine of the square root of k over mt is exactly what we had in our original function. So that we see that x double prime is negative k over m times our x of t function. So this is negative k over m times x of t, so that x double prime of t does turn out to be equal to negative k over m times x of t. Now, just to become familiar with the trigonometry that we're going to need later on, I'm simply going to assert for the moment that this form, b cosine of an angle plus c times the sine of an angle, can be written as a times the cosine of that same angle plus a phi that we'll call a phase angle. Now this is provable fairly easily just using standard trigonometric identities with which you should be familiar at this point, but you might find that you need a little bit of review to understand how we go from this form to this form. I'm not going to get into that here, but I can give you references to places in prerequisite courses where we have done this. Okay, anyhow, so for appropriate a and phi, we can express the solution to this equation in this form. Now, what does the graph of this function look like? Well, in the first place, if we graph simply a cosine of t, that's a graph, periodic function, goes on forever in both directions, and it goes through, or it oscillates between y values 1 and negative 1. Has a period of 2 pi, and this would just be y equals cosine of t, let's say. Now, if we put an a out here in front, this increases the values of y accordingly. Instead of running from negative 1 to 1, the values of y are going to run from negative a to a. So we can represent that as an oscillating function between y equals negative a and a, function of this nature. The period is still 2 pi, and this is the function y equals a cosine of t. Now we'll see in a minute what the square root of k over m and the phi do to this function.